This is my favorite test, the direct comparison test. In the direct comparison test, you compare your series to a known series that you already know whether or not it converges or diverges. And what it says is, if the series a sub n and the series b sub n, if a sub n comes underneath b sub n, that a sub n converges if b sub n converges, and a sub n diverges if b sub n diverges. What that means, this is my a sub n here. If I just simplify this down a little bit, that's n to the 1/2 over n squared plus n. If I just look at what's in the front, I can compare that to 1 over n to the 3/2. If you subtract your 2 minus your half, you get 3/2 on the bottom. So I know that this series, that's a p-series where p is greater than 1. So because this is a p-series where p is greater than 1, this series is going to converge. Now if I was to sketch that, 1 over n to the 3/2, or, no, I don't want to sketch it. If you think about this part is essentially 1 over n to the 3/2 plus n. So it's almost like you've got plus some more crap out here. What is this going to do to this series? Is it going to make the bottom greater or the bottom smaller? Well, it's going to make the bottom greater, which in turn would make this p actually even bigger than 3/2. So because this series converges, by the direct comparison test, I can say that this series converges as well. Essentially, you're just simplifying series down to make them look like other series. And there's actually, you can actually show it algebraically using the limit comparison test. I'm going to do that on A, but then on these two I'm just going to use the direct comparison test. This one, I can use the limit comparison test. I can compare this to 1 over n, which I know this diverges. Okay? So I'm going to use the limit comparison test that says the limit, as n approaches infinity, of the series that I'm given over, divided by, my new series. If this answer is bigger than 0, then it's going to behave the same as these. If it converges, it converges. If it diverges, it diverges. So if I work that out, that's the limit as n goes to infinity of 10n squared over n cubed minus 1 times n, which would be the limit as n goes to infinity of 10n cubed over n cubed minus 1. Well, that limit is 10. Well, 10 is bigger than 0. So that tells me that it's going to do whatever these do. This one diverges, so this series will diverge as well. Here I'm just going to compare this, because as I go to infinity, that 2 is not going to do a whole lot. This is going to be basically the same as 1 over n cubed. This is a p-series. P is bigger than 1. That's going to converge, so my series is going to converge as well. The same thing here. There's no difference in these problems, really, with the minus 1 and the plus 1. I'm going to compare this to 1 over n cubed, so it's also going to converge.